Message from Nishpesh sir, if there is a class.
Yes, sir.
Yes. Today you did not get that.
I got. I don't know about others.
So meanwhile, let us look at this type of questions. Okay, and since we have mentioned what will happen if we have a common ion, and in this cases we will not have a common ion, as you can see. So can you write the first question first of all? Anna, we will discuss this first, and then you can do this rest of them similarly. Okay, write the question.
Done, sir.
Done. Okay. So the first thing in this question is that you have to calculate the pH, right? So we want the concentration of H plus ions, right? Yes or no?
Yes, sir.
So we want the concentration of H plus ion. Fine. So both of calculate the pH of the resultant mixtures. So we are mixing CaOH whole twice and HCl. Now, obviously, you can see that they can react because CaOH whole twice is a base, HCl is an acid. Okay, so first of all, what we will do, we will have to calculate the number of moles of CaOH whole twice and the number of moles of HCl. Then only we can do the reactions. So stoichiometry from here, right? So first of all, what we'll do, we'll calculate the number of moles of CaOH whole twice. So we have 10 ml. We know that molarity it is equal to molarity it is equal to number of moles divided by volume, right? And from here I can say that number of moles will be equal to molarity into volume. So the molarity of CaOH whole twice is 0.2, right? Yes or no?
Yes, sir.
Okay, and the volume is 10 ml, correct?
Yes.
Yeah, 10 ml. So if I will write the units, you can say that 0.2 moles per liter into the volume is 10 ml, right? Milliliters. So liter and liter units will cancel each other out, and then you will get 2 millimoles. Yes or no? This milli and then mole. Okay. Any problem?
No, sir.
No problem, right? So this milli is nothing. Milli is just 10 to the power minus 3. Okay. It is a word that represents the number 10 to the power minus 3. Similarly, can you find this is the number of moles for CaOH whole twice, right? CaOH whole twice. Can you find the number of moles of HCl also?
Yes, sir.
Calculate this. Send the answer in chat. Write the A question, guys. Sarah and Zainab. Sarah and Zainab, write the A question. Yes, correct, Samara. So similarly for HCl also we'll calculate the number of moles, and the number of moles will be equal to the molarity, right? The molarity is 0.1 molar. That means 0.1 moles liter inverse into the volume is 25 milliliters. Liter and liter inverse can cancel each other out. Then you will get the number of moles as 2.5 millimoles. 2.5 millimoles. Okay. Now we have 2 millimoles of CaOH whole twice, and we have 2.5 millimoles of HCl in a particular solution. Now both of them can react with each other. So you will have to write the reaction. And now here the reactions are important. You have CaOH whole twice CaOH whole twice plus HCl. So you can see what will happen. You will form salt and water. So first of all, you form water. Okay, first of all, you form water, H2O. Now you can see what remains, CaCl. Right, and Ca, it will be Cl2 because Ca has 2 positive charge and chlorine has 1 negative charge. Okay, so the valency, Ca has the valency of 2, chlorine has the valency of 1. So criss and cross, and you will get CaCl2 whole twice. So this is the formula for CaCl2. Next is balancing this. So balancing this, if I will write 2HCl, then it is completely balanced. Can you please check that and tell me? 2HCl. Yes or no?
Yes, sir.
Okay. Now we have to write the react statement. Okay. So how will I write? I will say that 1 mole of CaOH whole twice reacts with 2 moles of HCl. 2 moles of HCl. Yeah, Samira, बोलिए.
So in front of H2O, we have to write 2, right?
Yeah. Yes, correct. In front of H2 also 2. Yeah. Okay. But we are more interested here. Okay. So what we have written, 2 moles of CaOH whole twice reacts with 2 moles of HCl. And how many moles of CaOH whole twice do we have? We have 2 millimoles, right?
Yes, sir.
Okay. So we will write 2 millimoles of CaOH whole twice will react with 4 moles of HCl. Yes or no? 4 millimole. Yes or no, guys? Tell me. I hope you guys are fine with this. If 1 mole requires 2 moles of HCl, then 2 millimole will require 4, just the double.
Yes, sir.
Everyone is fine? Yes or no? Tell me.
Yes, sir.
Okay, so this is a theoretical amount that we need to react the complete 2 millimoles of CaOH whole twice. But now you tell me, do we have 4 millimoles of HCl, or do we have less, or do we have more?
Less.
Less. Okay, so we'll write HCl is less than needed. Right? HCl is less than needed. Okay, fine. If HCl is less than needed, then what we can say, how much HCl is present? 2.5 moles, 2.5 millimoles, correct? Yes or no?
Yes, sir.
No, 2.5 millimoles. Now from I can write the whole statement from HCl also, and you can see that if HCl is less than needed, it will be limiting reagent. You remember this? Yes or no?
Yes, sir.
It will be limiting reagent. Limiting reagent is concept from the first chapter. Limiting reagent, and it will get completely consumed. It will get completely consumed. Now you all will see here that I can say the next statement, that is, if there is 2.5 millimoles of HCl, है ना? So 1 mill. Wait a second. I'm writing one thing. 1 mole of HCl reacts with half moles of CaOH whole twice. Just read this statement and read this equation and tell me, is it perfectly fine? Yes or no? This last
Yes.
statement makes sense, all of you? Yes or no?
Yes, sir.
Yes, no? So HCl, the number of here we have 1 CaOH whole twice, and here we have 2 HCl. Half of it is required. So we have one HCl, we will require half of CH2. And how much moles of HCl do we have? 2.5 millimoles. Hai na? So we can also write 2.5 millimoles of HCl will react. 2.5 millimoles of HCl will react with 2.5 by 2 moles of, sorry, by 2 millimoles of CaOH whole twice, है ना, CaOH whole twice. Now amount of CaOH whole twice remaining. So initially, how many millimoles of CaOH whole twice was present? We had 2 millimoles, right? So we had 2, and how much is reacted? This much amount is reacted, 2.5 by 2, right? This is the amount that is reacted, and this is the number of millimoles of CaOH whole twice that will be present in the solution after the reaction. So can you tell me this will be what? 4 minus 2.5 divided by 2. What will be the answer, guys? Tell me. 1.5 by 2, which will be equal to 0.75 millimoles. Correct? Yes or no?
Yes, sir.
Any doubt, guys? Yes or no? Tell me.
No,
All
sir.
of you got this answer?
Yes, sir.
Right. So this is the amount of CaOH whole twice is remaining. And since HCl is the limiting reagent, HCl will not be present, right? HCl is completely consumed. In the reaction we have in the solution, we only have CaOH whole twice. And how many CaOH whole twice? We have 0.75 millimoles of CaOH whole twice. CaOH whole twice. So now we need to find the molarity of solution. This will be equal to, molarity of solution will be equal to, according to CaOH whole twice, what will be the molarity of solution? The molarity of solution will be 0. Let me write it like this. The number of moles of CaOH whole twice divided by total volume, right? Volume. Now, how many millimoles is present? 0.75 millimoles of CaOH whole twice, and the volume will be, now here for when you're writing volume, you should be careful because we are adding 10 and 25, right? So this water will be present, 10 ml and 25 ml. Total it will make how many? Total it will make 35 milliliters. So milli and milli will cancel each other out, and you will get 0.75 divided by 35 moles per liter. Moles per liter. This is the molarity of the solution. Now please remember that the concentration of OH negative will be equal to 2 times the concentration of CaOH whole twice. Why? Because we have 2 OH whole twice in 1 molecule of CaOH whole twice. We have 2 OH groups. We have 2 OH groups attached in 1. So if I have only 1, then I will be getting 2 OH negative. And hence, if I have 1 mole of CaOH whole twice, I will be getting 2 moles of CaOH whole twice. Now I can write this as 2 into 0.75 divided by 35 moles per liter. Yes or no? Tell me. Right, guys?
Yes, sir.
Right. Okay, fine. Now it is going to be simple. You will just calculate the pOH. I hope you remember that there is a relationship between pH and pOH. Yes or no, guys? pH plus pOH, it is equal to 14. We have done that, right? When you calculate pOH, it will be minus log of 2 into 0.75 into 1 upon 35. I can write this as, and I will just keep the minus sign inside. It will be minus log of 2 plus log of 75, right? Minus log of 10 minus log of 35. Just tell me if this whole thing makes sense, and then calculate the pOH. Calculate the pOH. Okay, so one thing that I will ask you guys is don't solve these type of what I can say, divisions and all, okay? Because whenever you know that you have to take logs, right, at the end of the day. So it is better if they are in, if they have not solved, because whenever you solve something, you are going to approximate. So then approximate. If you do 2-3 approximation, it will give you a significant error. So when you have fractions or something, na, like way early in the answer, then don't solve or simplify those fractions. Try to keep the fractions as fractions only. Log 2 is 0.3, right? Plus log 75. Log 75, I can write it as 5 into one thing you can do is you can resolve this. I mean, simplify in the sense, don't keep it in fractions. You keep it in fractions, but not in decimals. So if I want to do that, I can do that now. That will make things easier, I guess. 2 into 75 upon 35 into 1 by 10. So 5 sevens are 15s are right. So I can write this as 15 and 35 as 7. Now you can solve this. This will be log 5 and 3 5 is 15, right? So this will be 0.48 plus 0.70 minus 1 minus 0.84. Tell me if you get the POH, okay? Yeah, tell me.
Sir, is it minus 0.36?
0.34 आ रहा है
36.
minus 0.36. Wait a second, let me check. Okay. सारा ये आपको -1.04 आ रहा है. अच्छा. Okay. No, so I did one mistake. Can you guys see that mistake?
Sir, I guess it is a log 10.
It will be log 100, no?
Yes, I was thinking about that only.
So log 100 कर लीजिए इसको 2 कर लीजिए. Then I think you will get 1.36 now. Because जब 1 था तो you were getting 0.36 ना. Now we have -1, so this will be minus, like it will increase in magnitude by. This will be -1.36. Okay, -1.36. So POH is equal to 1.36, and the pH will be equal to 14 minus 1.36, which will be equal to 12.64, no? Right, guys? 64. This will be the pH. So obviously it is basic because we have OH minus. So write this down. Write this down.
Done, so.
Then all of you. Okay. Now let us see this question. Okay. I'm asking you things orally only. है ना? बस आप थोड़ा सा ध्यान लगा के बस आप जवाब थोड़ा दे दीजिए. ठीक है? Just put in little effort and you will get the answer. Okay, for the B1. Okay, all of you ready? Yes, Samaira, Aisha, Sarah, Zainab.
Yes, sir.
Yeah. Okay, fine. So first of all is we need the number of moles. है ना? Number of moles of acid and base. I hope you have identified that there is an acid here, there is a base here. Yes or no? H2SO4 is acid, CaOH whole twice is base. Correct?
Yes, sir.
Okay. Now you tell me what will be number of moles? It will be equal to the molarity into the volume. So molarity of acid, that is H2SO4, is how much? Tell me what is given.
0.01 into 10.
0.01 into 10. This will be equal to 0.1. Yes or no?
Yes, sir.
Millimoles. What about base? What about base?
0.1 million.
0.1 millimoles. And a milli is nothing. Milli is just a number that is equal to 10 to the power -3. Fine. Okay. We have got the number of millimoles. Okay. We have got the number of millimoles. Then you look at the reaction. So for looking at the reaction, we saw that there are 2 OH for each base. For each base in the first question, and only 1 hydrogen for each acid. Now you tell me how many hydrogen is there in H2SO4? In one H2SO4, how many hydrogen is there?
2.
2. And how many OH negative in CaOH whole twice? 2. And that means for 1 mole of H2SO4, we will need 1 mole of CaOH whole twice. Yes or no?
Yes, sir.
For 1 acid, we need 1 base. Is everyone fine with this? Aisha, Zainab, Sarah?
Yes, sir.
Right? What about you guys? Sarah?
Yes, sir.
Right? Okay. Okay, Zainab, you're understanding. Now, if I need only 1 mole of acid for 1 mole of base, so we have 0.1 mole of. for 0.1 millimole of H2SO4, it will react with how many millimoles of COOH whole twice, guys? How many millimoles? How many? I did not hear that. Can you repeat that?
0.1.
0.1 only, right? So now you can see na 0.1 millimole of CaOH whole twice. So what do you guys think? What will remain? H2SO4 is extra, or CaOH whole twice is extra? Is there anything which is extra in the solution?
No.
No, na? So they both will react with each other, and neither H2SO4 will be left in the solution nor CaOH whole twice will be left in the solution. And hence what I can say, the number of moles of H plus is nothing, right? It is not dependent, it is not nothing, but it is not dependent either on H2SO4 or CaOH whole twice. It will be equal to as that of neutral solution, that is 10 to the power minus 7. And if you have added the same amount of acid and the same amount of base, the solution is going to be neutralized completely, and the pH will be equal to how much? For neutral, the pH is, for neutral substance, the pH is how much?
7.
7, right? The pH will be 7. Got it, guys? Yes or no? Tell me.
Yes, sir.
Right. So now in this case, we will have, here we will have 1 millimole, and with this also we'll have 1 millimole of both the things, H2SO4 and KOH. Yes or no?
Yes, sir.
But we can see that I need 2 moles of KOH to react with 1 mole of H2SO4, correct?
Yes, sir.
Because here we have 2 H2 and here only we have 1 OH whole twice. So we can say that KOH will be completely consumed and the solution will be acidic. How much acidic we don't know right now. You can calculate and tell. So you write the C question and then you will calculate the pH of this solution. It will be acidic. That means it should be less than 7. So you also make a judgment before calculating the exact value that it should be acidic or basic. So that when you get an answer and if it is absurd, so you know that you're doing some mistakes here and there. Okay, so let me know if you're done.
Done, sir.
Yeah, okay. Fine. Now, let us write buffer. Now, we will write about buffer solution. Write the topic. Buffer solution. What is the buffer solution? First of all, we'll write the definition of buffer solution and then we will start to understand why it is used. Okay, why it is used and where is the significance of buffer solution. So please write the solution. Which resists the change in hydrogen ion concentration on addition of small amount of acid or base. Okay, small amount of acid or base. Write this down, then I will ask you a question. Don't write this question, okay? Just write till here and tell me, what do you think? What should be the pH of buffer solution? Tell me. Any idea? If no idea, then it's fine. Okay, raise your hand if you think it is 7. No. Okay. Okay, Aisha thinks it is 7. What about others? Samaira, Sarah, Zainab. Yes, Samaira, can you comment on some? I mean, it will be 7, more than 7, less than 7, or 7 by looking at the definition.
More than 7.
More than 7. Okay. What about Sarah? Zainab, you can send the answer in chat if you want. Okay. Zainab also thinks more than 7. Sarah, what do you think?
I'm not sure.
Not sure. So you're not sure. Like, so confusion kya? You're not sure about what? Do you have any answer in mind and you're not sure, or you don't have any answer in your
don't
mind?
know.
Achha, you don't, I mean, okay, fine. Aisha, you want to say something, or you're, oh, I just lower your hand because I saw that you are okay with 7. You're still okay with 7, right?
Yes, sir.
Okay, fine. First thing is that, okay. So this definition, it hints around something. I hope all of you will, if you have set a particular value for pH, then I understand that this particular definition, it is hinting that the pH of a buffer solution should be of a particular value. Is that right, guys? That is this definition hinting that the pH of a buffer solution should be something which is constant, and all the buffer solution should have a particular value. Is it hinting something like that?
Yes, sir.
Yes. Okay, fine. So please remember, don't get confused by these type of definitions. So what it is saying, that the solution which resists the change in the hydrogen ion concentration, है ना? Hydrogen ion concentration, it is not specifying at what concentration. So the buffer solution can be prepared. It can be prepared with any pH. Okay. Buffers can have pH value ranging 0 to 7, 0 to 14. Okay. 0 to 14 तो नहीं होता है, 1 to 14, sorry. 1 to 14. What does that mean? If I prepare a buffer solution, है ना, and the pH is 2, I can also prepare a buffer solution where the pH is 8. Okay, where the pH is 8. Both of these solutions are buffer solutions. Both of these solutions are buffer solution. The definition of buffer solution is not revolving around any pH. It is not revolving around any particular pH, but for a particular buffer solution, there should be a particular pH. That means if I add a small drop of acid, if I add a few drop of acid, that means H plus, then it is not going to change the pH of this solution. So we will have to prepare something which, on addition of H plus or the addition of OH negative, is not changing the concentration of OH and H plus in this particular solution, and the pH is maintained as 2 even after the addition of some acid or bases. And in this case, what happens, even after the addition of some acid or some base, the pH should be maintained at 8. It should not get very high or very large than 8 or smaller than 8. Okay, so this is the definition of a buffer. Buffer does not have a particular pH, but a particular buffer will have a particular pH. Is that something that you can remember? Yes or no, guys? Tell me.
Yes, sir.
Okay, so buffer solution. So we will have a solution. Uska kuch concentration hoga H plus ka, and that concentration should be maintained. Okay, for that particular buffer, we can prepare another buffer solution. Okay, we can prepare another buffer solution. Now let us think. Now this is interesting, because what we are doing? We are adding H plus ions, but we are designing a kind of a buffer. We are designing a kind of solution in which, after the addition of H plus, the pH is not changing. The pH is not changing, and the inspiration of buffer, it came from the human, not human blood, I think all blood, but I can say that human blood it has. human blood, it has somewhere around 7.35. This is the pH of human blood. So even if we eat very acidic food, even if we eat very acidic food, then also it does not get less than 7. Then also it does not get less than 7. So there is even a diet around this pH. It is known as the alkaline diet. Have you heard of this? No, no one has heard of this. Not very much interested in nutrition. No, Zainab has not heard. Okay. So in alkaline diet, you eat everything which is which is not acidic, just to maintain the blood pH. But they don't know that the human blood itself is a buffer. What it can do, it can maintain the pH around 7.35. Okay. So it will not get less than 7 anyhow. So now let us think. We will this solution may. In this solution, we already have some H plus ions. We already have some OH negative ions. We have H plus ions, and we also have some OH negative ions. Now, what I am doing, if I am adding acid, then some amount of H plus will be added. Now, when I'm adding some H plus, then the buffer will do what? Buffer would decrease the concentration of H plus, right? The same amount of H plus should be reacted. Yes or no? The same amount. Should be reacted or consumed. Then only the pH will be maintained. No? Yes or no, guys? Tell me that. Bataiye.
Yes.
Right. Then only the pH will be maintained. Then only pH will. Now, if I add a base, then if I'm increasing the concentration of OH negative, then this same amount of OH negative should be consumed. Should be consumed. Okay, fine. That means in this solution, we should have two types of things. We should have something which is acidic, and we will mix some acid, and we will mix some base. We'll mix some acid, and we will mix some base. When we mix acid and base, that means what we are doing, we are making some kind of salt. Yes or no? Tell me.
Yes, sir.
Right, we are making some kind of salt. Okay. Now, if I want to prepare a buffer which is less than 7, okay, the pH is less than 7, then what I will do, I will increase the amount of acidic content. And I will have some less amount of base. And if I want to create a pH which is greater than 7, then I will just do the reverse. But what should be that acid? What should be that base? We will understand that. First, let us do and talk about this salt, right? Because what we are doing, we are preparing salt. Okay, we are preparing salt. Now, when we talk about salt, and when salt is in water, then what happens? We have NaCl. If I add this in water, what will happen? It will completely dissociate to NaCl, Na plus, and Cl negative. Yes or no, guys? Tell me. Yes or no?
Yes, sir.
Right. Okay. But this is only possible when you have a salt which is prepared by. Now, this NaCl is prepared by which things? It's prepared by NaOH plus HCl. Yes or no? Right? Yeah, HCl. Sorry for this. I should have written H2O. You tell me about this. NaOH plus HCl, it is going to give me NaCl, and both of these, base and acid, is what? They are strong acid and base. Yes or no? They are strong acid and strong base, right? Now, when we add strong acid and strong base, they completely dissolve in water. But if I will have, see, strong acid plus strong base, another salt of strong acid plus salt base, what will happen? It will completely dissolve. Now, let us look why it is dissolving. See, when you add NaCl, what it can do, it has H and OH. So it could have made NaOH plus HCl also. Yes or no? See, NaOH and HCl. Right, guys?
Yes.
Yes,
Hmm?
sir.
But we know that this is a strong electrolyte and it completely dissociates, right? So when it completely dissociates, that means this OH and H plus, it will combine together to form water, and you will get Na in aqueous solution and Cl minus in also aqueous solution, right? So only because we have strong acid and strong base, that means these are prepared by strong electrolytes. This is completely dissolving. It is completely dissolving. But let us look at something which is a mixture. Something which is a mixture. Let us start with CH3 COO Na. Okay, COO Na. So as you can see here, this is negative and Na is positive, and this is made by the acid, that is CH3 COOH plus NaOH, that is the base, and we get this salt. Yes or no? Sodium acetate. This is a salt. Correct, guys? Yes or no? Tell me. नहीं दिख रहा क्या salt आप लोगों को? Do we have a consensus that this is a salt? Yes or no? First, tell me that.
Yes, sir.
Right? All of you are fine now with CH3COO negative and Na positive as a salt? No. क्या हो गया? Okay, let me prepare the salt then. CH3 COOH plus NaOH. So what I can write? CH3 COO negative, right? Because H plus will be liberated. This is acid plus Na positive, and from here OH negative and here H positive, they will form H2O. Then these two will combine, and you can write this as CH3 COO negative and Na positive, right? It is as we have written HCl, right? HCl. So Cl had negative because it was liberating H plus ions. And similarly, here we have CH3 COO negative and Na positive. All of you guys are fine, na? Yes or no? Tell me.
Yes.
Yes.
Okay, fine. CH3 COO negative, Na positive. This is a salt. This is a salt. Now, when I will dissolve this salt, CH3 COO negative, Na positive, then what is going to happen inside water? So this CH3, we will get CH3 COO negative plus Na positive. Now, and here we also have H and OH. Now we know that if I will form NaOH, then it is a strong acid, and it will be completely dissolved in the solution, and it will be completely ionized. There will be no molecule of sodium hydroxide present. But if I see this molecule, that is CH3COO, and if it combines with the hydrogen of the water, then it is going to form CH3COOH. But this is a weak acid, and if it is a weak acid, then it will be not completely dissociated, and it will have CH3COO negative and H positive ions, but there will be some molecules of acetic acid also there. But if I talk about Na positive in water, and if it reacts with water, let us say OH negative, then it is not going to form sodium hydroxide, because we know sodium hydroxide is completely dissociated. So we'll have Na positive and OH negative, but no molecules of NaOH. Yes or no? Tell me that first. Right, guys?
Yes, sir.
Okay, fine. That means if I have a salt of weak acid plus strong base, then what is going to happen? If I have a salt of weak acid and strong base, then in this case, we can also write about the hydrolysis. How much of this will be hydrolyzed? The hydrolysis constant. Salt hydrolysis is actually not in your syllabus, so I am kind of whether to give you those things or not. Okay. So if you have weak acid and strong base, then I can say that this CH3COO negative will react with H positive and it will heat up some H positive. Yes or no? Tell me. Because it is a weak acid, it will be interacting with the H plus ions in the water and it will form acid, that is CH3COOH. Right, guys? Yes or no?
Yes,
Yes,
sir.
sir.
Okay. But will the Na positive will react with OH negative of water? Will it form NaOH or it will be dissociated? NaOH will be in the form of Na positive or it will be in the form of NaOH? What do you think? Where will be the equilibrium? This side or this side? Tell me, B side or A side? It will be on A side, no? It will be completely dissociated, right? NaOH.
Yes, sir.
Right? NaOH will be completely dissociated, but CH3COO negative will be eating up some hydrogen. That means when we have weak acid and strong base, then H plus is consumed. If H plus is getting consumed, then what it will lead to? It will lead to alkaline solution. It will lead to alkaline solution. Yes or no? Tell me.
Yes, sir.
Right? Because we are eating up, we are consuming H plus ions and it will lead to alkaline solution. It will lead to alkaline solution. Now, just to give you the formula, and we are not going to do any derivation of the formula. You can write this, that the pH of weak acid and strong base, pH for these type of acid is pKa, sorry, pKw, half of pKw plus half of the pKa of the acid, and half of the log of the concentration. The C is not constant, C is equal to concentration of the salt. Okay, concentration of salt. Okay, so this is something that you have to write. Weak acid plus strong base, then H plus is consumed and it will lead to alkaline solution. And this formula you can write, but again, this is not going to be asked in your syllabus, but we need this in order to understand buffer, and hence I am teaching this. Done?
Yes, sir.
Okay. Now, opposite thing you can write, if you have weak acid and strong base now. So here we'll write, if we have a strong acid, salt of strong acid and weak base, then what will happen? Weak base will be formed in water by consumption of OH negative, because the conjugate acid of weak base will be consuming the OH negatives and it will be forming the weak base, because we are forming the salt that is formed by strong acid and weak base. So in that case, opposite thing will happen. H plus is consumed and it will lead to alkaline solution, and in this case, negative will be formed by consumption of OH negative, leading to this solution getting acidic. Okay, and in this case, the pH will be, so pH will be half of pKw minus half of the pKb minus half of log C, and again C is the concentration. I hope all of you remember that pKw is equal to 14, so we can also write this as half of 14 will be 7 minus half of pKb minus half of log C. This is going to be the pH. Okay, this is going to be the pH.
Done, sir.
Okay, if we have salt of weak acid and weak base, then it is going to, I will write the formula that pH, this will be equal to the half of pKw plus half of pKa minus half of pKb minus half of pKb. So you will have 7 plus half of pKa minus half of pKb. This is the pH if we have weak acid and weak base. Okay, weak acid and weak base. In this case, you can write some result. If you will have, if pKa, if the pKa is greater than pKb, then solution will be, try to tell me, if you have pKa greater than pKb, then the solution will have what? It will be acidic, basic, or neutral. pKa is greater than pKb. Yes, you just need to tell me if pKa is greater than pKb, then the underlined part, the value of underlined part will be positive or negative. If pKa is greater,
Positive.
positive. That means we are adding something to 7. Yes or no?
Yes, sir.
If we are adding something to 7, then what will be the solution? Solution will be alkaline, basic, right, guys?
Yes, sir.
Then we have pKa less than pKb, then solution will be basic, basic means acidic, sorry. Acidic. Third is if pKa is equal to the pKb, then solution will be neutral. Done, guys?
Yes, sir. Done.
Okay, write a question. pKa of acetic acid and pKb of ammonium hydroxide. Ammonium hydroxide are 4.76 and 4.75. Please remember this is not pH. These are the pKa and pKb. Okay, pKa and pKb. 4.75 and 4.76. Calculate the pH of ammonium acetate solution. Okay, this is easy because we have both of these are very small, right? Both of these are very high, pKa, pKb, and then we can say that it is what it is. We have here a solution of acetic acid CH3 COOH plus NH4OH. It is going to give me CH3 COO negative and NH4 positive. Now both of these things are what? Both of these things are, this is weak acid, this is also weak base, and hence we can write the pH. This will be equal to pKw, that means 7 plus half of pKa minus pKb. pKa minus pKb. So you can write 7 plus half of pKa is 4.76 plus 4.75. This will be equal to 7 plus, the value will be quite small, I think. Anna? Oh, sorry, wait a second. This will be minus. So this will be equal to how much? Half of 0.01. This will be equal to 7 plus 0.01 divided by 2. 0.005. So this is the pH. Done?
Yes, sir.
Okay. Right, next question. .02 molar solution of pyridinium hydrochloride. Pyridinium hydrochloride has pH that is equal to 3.44. 3.44. Calculate the ionization constant. Ionization constant of pyridine. So in this chapter, acid and bases, your main barrier will be the chemical names. I think you guys have never seen this thing, never heard of this term, that is pyridinium hydrochloride. So that is why more questions, if you do more and more questions, then you will be exposed to different acids and different bases. So pyridine is something like this. It is like benzene, but instead of one carbon, we have replaced that carbon with nitrogen. So this nitrogen has a lone pair, and these are the bonds. Okay, plus we have HCl. Okay, and they will form a salt, and you know that this N, it can abstract a hydrogen like this. It can make a bond with hydrogen like this. It will get a positive charge here. This nitrogen will get a positive charge, and here you will have the chlorine negative. Okay, so this positive negative will interact with each other, and this is the salt they are talking about. This is the salt they are talking about. Now, whenever you have anything which is organic, that will be weak. Either it is acid or base. And you can see that this is an acid, and this is a base, and this is a weak base. And we can classify the salt as salt of strong acid and weak base. Yes or no, guys? Tell me.
Yes, sir.
No problem till here, all of you? Any problem till here? Aisha, Samaira,
No,
No,
Samaira. So now when we have salt of strong acid and weak base, we write the pH. It is equal to half of pKw, right, minus pKb minus half of log C, right? We have over it as well. Sorry. So this will be equal to 7 minus half of the pKb. What is the pKb? pKb, we have there asked the ionization constant. We have to calculate the pKb. Okay. pH they have given. pH is to be half of pKb minus half of log of how much? 0.02, no? 0.02. The pH is given to be 3.44. Now I will take this and I will put it here. Half of pKb, it is equal to 7 minus 3.44 minus half of log of 0.02. That means 10 to the power log of, so the log of 2 minus 2, right guys? Because I can write this as 2 into 10 to the power minus 2. So this minus 2 will come below the log. Now come down, and that will be equal to log 2 minus 2. Right? Now, so now you can write the pKb. You can calculate this value, multiply this by 2. That is 7 minus 3.4 and half log 2 minus 2. We'll calculate this. Then you will get the pKb. Once you have got the pKb, then what you are going to do? You got the pKb. Okay, so you will write Kb will be equal to, what is pKb? Minus log of Kb. That means 10 to the power Kb, 10 to the power pKb will give me 10 to the power pKb will give me the Kb, similar to pH, and hence you will write Kb, it will be equal to 10 to the power minus of pKb. Now whatever the pKb was present, so whatever answer you get, then you will do the Kb equal to 10 to the power minus pKb. You will apply the logs, and then you will get the answer of this dissociation constant or the ionization constant of pyridine, that is the base. Okay, so write this down. You will complete this, okay? Because we also need to do buffer. I just wanted to give you at least two questions so that you get an idea if you have any salt hydrolysis questions later on. It will not be there in the examination, I hope so, but पता नहीं ना आपके स्कूल में कैसे हैं, क्या करा दिया है, क्या नहीं कराया. Have you guys done this part from school, in school? Samaira, Aisha, no idea.
No, sir.
नहीं, ये मैं से बोल के हटा दिया है सिलेबस से आपके स्कूल में कि सॉल्ट हाइड्रोलिसिस नहीं आ रहा है. Did they say something like that? No.
No, sir.
No. Okay. Write this down. Are Atif, why are you late?
No, sir, I joined at 6:30.
But you usually join at what time?
So the message said 6:30 to 8:30.
ओहो, आप कहाँ रहते हैं? Where do you live, Atif?
Sorry, sir?
Where do you stay?
In UAE, sir.
UAE. अच्छा. हाँ, तो I think that was Riyadh time. 6:30.
No, sir, usually the message says 7:30 to 9:30. This time it said 6:30 to 8:30. That's why I joined.
नहीं, फिर आप 7:30 आइए. आप पहले आ गए हैं
7:30 only?
हाँ 7:30 to 9:30 same timing.
Okay, sir.
Okay,
Okay, sir. Thank you.
you have the number and all na? Okay, so let me know guys, Samaira, Aisha, Sarah, Zainab, if you're done.
Done, sir.
Done. Okay, fine. So देखिए अब है ना, by salt hydrolysis we know that now we know if I will have a salt, okay, if I have a salt, if I have a salt of strong acid and weak base, है ना, strong acid and weak base. So from the strong acid and weak base, so from strong acid I will get the, from strong acid I will get the conjugate base, and from weak base I will get the conjugate acid, है ना, conjugate acid. Now this conjugate base, it will hydrolyze easily, it will get dissolves. But this conjugate acid, what does it do? Tell me, what does it do? The conjugate acid of weak base, फिर से बताना पड़ेगा आप लोगों को. For example, Na strong acid HCl plus weak base NH4, strong acid HCl, weak base, what I can take as weak base NH4, sodium hydroxide. Hydroxide, I think it is a fine base. Hydroxide, let us take an H4OH. Okay, then what I will get? I will get NH4 positive, Cl negative. This Cl negative, it will dissolve. Cl negative कुछ नहीं करेगा. Cl negative will not do anything. Cl negative will not do anything. But what the NH4 positive will do, it will eat OH negative because it wants to stay like this. It don't want to stay in dissociated form, and that is why it is a weak base. All of you understand that? Yes or no? Tell me.
Yes, sir.
Okay, fine. So when you have weak base, strong acid, and we have weak base, then the conjugate acid will eat OH negative, to form the weak base. That means if I prepare a solution, and in this solution if I add strong acid, salt of, okay, again salt of strong acid and weak base, then I have taken care of, if I add OH negative, if I add OH negative, that means base in this, then pH will be maintained, will not change. Yes or no? Tell me. Because whatever OH negative I am going to add now, what is going to happen? This NH4 positive will eat it up. Yes or no?
Yes.
If I will have the weak base. Okay, so this is how. So we have taken care of the OH negative. Yes or no? Tell me, guys.
Yes, sir.
Okay. So we have taken care of OH negative. Now we have to take care of the H plus. What will happen if I add H plus ion? How should we take care of H plus ion? Now what I will do, if I want to take care of the H plus ion, then I will add a base. Okay, in this solution, what I will do, I will add a base. And I will add a weak base. Okay, what I will do in this solution, I will add salt of strong acid and weak base and a weak base. Okay, so this solution, it is going to be basic. So I have here a solution which has weak base. So if it has weak base, that means it can consume H positive ions. And then I will add the salt of strong acid and weak base. It is going to take care of the OH negative ions, and hence I have created a buffer. And this buffer is going to be slightly basic because I have added a weak base initially, and then I am adding a salt. So generally the salt, they will not change the pH to a very high degree. So what I can say that if I add these two things and whatever is the pH after the addition of these two weak base and the strong and the salt of strong acid and weak base, it is going to give me a buffer solution. And it is going to give me a buffer solution because weak base is going to take care of H positive and the salt is going to take care of the OH negatives. Okay, so this is how we prepare buffers. So there can be two kinds of buffer. Buffers can be of two kinds. So for if we want to prepare a basic buffer, then what we are doing, we are adding a weak base first, and then we are adding its salt with strong acid. So first let us write number one, basic buffer. Basic मतलब ऐसा मतलब basic normie वाला नहीं basic. Okay, this means like alkaline buffer. Okay, not normal. Basic means ऐसे नहीं कि economical plan, basic plan, then you have business plan. No, not like that. Basic means alkaline basic. Okay, basic buffer. So what we will do, we will add equimolar concentration of equimolar concentration. Okay, equimolar हो गया तो concentration हो गया ना, equimolar quantity of a weak base and its salt with strong acid. Salt with strong acid. Okay, now what we can write about this type of solution, we can write about this type of solution that the salt that we are getting now, the salt will take care of the acidity part. Yes or no? Guys, salt will reverse the action of added OH negative ions. Okay, the salt, what it will do, it will reverse the action of OH negative ions, and the weak base, if I will have weak base, will reverse the action of H positive ions. It will reverse the action of H positive ions. Done?
Yes, sir.
Okay. Right, next, that is, so should we do an example? So we did, now you, if you understand it, that is fine. You'll get some questions, maybe what is buffer and all, not much more than that. So basic buffer, then you have acidic buffer. And this you can write equimolar quantities of weak acid and its salt with strong base. It's salt with strong base. Then again here we have weak acid and it's salt with strong base. So what we'll do, salt will reverse the action of addition of salt will reverse the action of addition of H plus ions, because we have a weak acid there, so weak acid will be formed. So for the formation of weak acid, we need the H plus ions. Then we have the weak acid
Done, sir.
Then all of you?
Yes,
Done,
sir.
sir.
Okay. What else? Achha. This topic again, it is not there. Okay. Syllabus, just I'm marking this out. So I'm just giving you the equation. Henderson Hasselbalch. Henderson Hasselbalch equation. Okay. Now, according to this Henderson Hasselbalch equation, for acetic buffer, the pH of the acetic buffer, whatever pH you want to maintain, then how are you going to choose it? You will choose the pKa, and the pH will be equal to pKa plus log of the concentration of salt that you have added and the concentration of acid that you have added. Okay, and the concentration of acid that you have added. Then for basic buffer, you will calculate the POH, and this will be equal to the POH minus log of the concentration of the base, will be equal to pKb of the base, weak base that you have taken, plus log of salt, that means the concentration of salt divided by the concentration of base. And in this way you are going to create the basic buffer. Okay, then you can write one more point at the concentration of salt is equal to the concentration of acid, then the pH of the acidic buffer will be equal to pKa. And similarly here, if salt at the concentration of salt that is equal to the concentration of acid, then also the pH will be equal to, sorry, POH will be equal to pKb, and in this case you can write the pH will be equal to 14 minus POH, and since POH it is equal to pKb, I can write pKb. Okay, so write these points, just keep them in your copy. Exam you're not going to get these in exams. You write this down, let me know if you're done.
Done, sir.
Done. Okay. Now, last thing, we have added acid, we have added bases. Now we are going to add salts into water. Okay, we are going to add what? Salt into water, and we are going to try to look at the how much of the salt is getting dissolved. Hai na? We did not, when we added the salt, we were looking how much of the salt is consuming H plus, or if it is consuming OH negative. It is made from different acids and different bases. Now here, what we are going to try, we are going to try to tell what is the concentration of salt that is dissolving. What is the concentration of salt that is getting dissolved? Okay, so we know that there are extremes of salts. Okay, there will be extremes of salt. There will be some salts that get dissolved in water completely. There will be some salt that don't get dissolved. Don't get dissolved. And there will be some cases in which partially dissolved. Partially dissolved. So we are more interested in partially dissolved cases, because if it is dissolving completely, that means it is made from strong acid and strong bases. And if it is not getting dissolved at all, that means it is it may be prepared by very weak acid and very weak base. And if it is partially dissolved, that means again we have two cases. It will be either from strong acid plus weak base, or it would have been prepared by weak acid and strong base Okay, so we'll be looking at how much of the salt is getting dissolved. So for this, I will write a simple equation first of all. Let us understand this first, because it is going to be very similar to whatever we have done till now in ionic equilibrium. So we have AgCl. This is a solid. This S means solid, not salt. And if I add this in water, then I will get Ag positive aqueous plus Cl negative aqueous. Yes or no, guys? Tell me. Right? Now tell me what will be the equilibrium constant for this case. What will be the equilibrium constant? Concentration of products upon reactant, guys. Can somebody please help me?
Ag into
Ag positive into concentration of
Cl.
Cl negative divided by the concentration of AgCl.
Yes.
Right, and we know that this is a solid, that means it will be a constant. Hence we can write K into the concentration of AgCl, because AgCl is also a constant. We'll keep them together, and this will be equal to the concentration of Ag positive and the concentration of Cl negative, and we can say that if I multiply both of these things, this will be equal to a new constant. Let us call that Ksp. Sp means solubility product. How much of the salt is getting dissolved? So here we have Ag positive and here we have Cl negative. So we are taking the product of the solubility, because the number of moles of Ag positive that is getting dissolved will be equal to the number of Cl negative that is getting dissolved. So if I say that S amount of Ag is getting dissolved and S amount of Cl negative is also getting dissolved, that means S amount of AgCl was S amount, I will say, but I can say that this is also solubility, this is also solubility, and if I'm multiplying both of these things, the concentration in the solution, that will be solubility product, and hence it is named as Ks, solubility product. That means the amount of Ag positive inside the solution and Cl negative inside the solution. This is the Ks. So write the topic solubility product and then write these parts. Solubility product. This is ekdam like the acid base thing. Okay, we have acid, then we dissociated it, and then we multiplied the pure in the water case to the constant, and we got the Ka, Kb, and here we are getting the Ksp. Okay, not at all different, it's very similar. Write this down, let me know if you're done.
Done, sir.
Done, all of you?
Yes.
And so let us just practice of like we are going to write the salt and we will directly write the KSP expression. Okay, थोड़ा उसमें practice कर लेते हैं, then it will be easy for us. So I'm writing a few salts and I will not write the reaction. You don't need to write the reaction because when I will give you examples, a few examples, you will understand how to write the KSP. So the number one is that we have written for AgCl. Let us write for PbCl2. This is the PbCl2 is our salt. So for this I can write the KSP. You can directly write KSP. It will be equal to the concentration of Pb2 positive into the concentration of Cl negative whole square. I hope all of you can understand this. Yes or no, tell me. If not, then I can explain this by writing the reaction that is happening here. अच्छा एक काम करते हैं, नहीं आप लोग ऐसे मत लिखिए, reaction लिखते हैं. We have space and all, no? It will be a practice for you guys also. This is the KSP. And this will form Pb2 positive plus 2Cl negative. Secondly, BaSO4. So we know barium, it is in second group. That is why Ba2 positive and SO4 is also 2 negative. So the KSP will be expressed as concentration of Ba2 positive into the concentration of SO4 2 negative. Right, the third part. C2S. Then it will get 2 copper molecules with 1 positive charge plus S 2 negative, and hence the KSP will be equal to the concentration of Cu positive squared, because we have 2 moles, into the concentration of S2 negative, है ना? बस यहाँ पे please take care that you may get some things wrong in the square and the charges. Okay, so take care of that. Fourth, now I hope you all can write. Yes or no, tell me. Right, you can write ना. AgI में लिख लीजिए आप, आसान दे देते हैं आपको. Write for CuBr. Again, you can also write for, let me give you one difficult one then. Ag2CrO4, इसका तो हम ही लिख देते हैं. This will be 2Ag positive plus CrO4 2 negative. The KSP for this will be equal to the concentration of Ag positive squared to the concentration of CrO4 2 negative to the power 1. So 4 and 5 के लिख लीजिए. I hope you guys can write. It's very simple. Write this down. Let me know if you're done.
Done, sir.
Done. Okay. Now I'm going to write a generalized formula. Okay, I'm going to write a generalized thing. Let us say that you have a molecule which is A X and B Y. Now you guys tell me, it will get dissociated into, what will be the charge on A?
Positive.
How much positive? You look here. This was Pb. What was the charge on Pb?
2 plus.
And what is the stoichiometry of Cl? Sorry, not the stoichiometry. How many Cl is present?
2.
2, right? Yes or no?
Yes, sir.
अगर आपको थोड़ा सा याद हो periodic properties we did ना. For example, I have to make a molecule which is calcium nitride. So we have calcium and we have nitrogen. Okay. What is the valency of calcium? It is 2. What is the valency of nitrogen? It is 3. Then we did criss and cross, right? So we got Ca3N2. This 2 was representing the charge on calcium. This N3 was representing the charge on nitrogen. So similarly, here also you will write A, which will have a charge of Y positive, and there will be XA molecules with Y positive charge. Similarly, you will have Y molecules of B with X negative charge. Okay, can all of you see this? Yes or no? Tell me.
Yes, sir.
Okay,
Yes.
now remember this KSP will be equal to the concentration of A to the power Y positive to the power X, because the stoichiometric coefficient. Again, here you will have B to the power X negative, and in this power you will have Y term because you have stoichiometric coefficient, that is Y. Done? Okay. Right, next the question. Okay. Write the question. Calculate the solubility of A2X3 in pure water. In pure water, assuming that none of the ions react with water. And they are given solubility product of A2X3. It is equal to 1.1 into 10 to the power minus 23. 10 to the power minus 23. Okay, so see how are you going to do this? First of all, we will write the dissociation of the salt. A2X3 will dissolve into water. Let me write it in equilibrium because equilibrium chapter. Equilibrium with, we will have two molecules of A with 3 positive charge, plus we will have 3 molecule of X with 2 negative charge. Yes or no? Any problem till here?
No, sir.
No. Okay, now please listen. Let us say that I took a salt, and I took salt, let us say 5 moles. I take 5 moles of salt. I added that salt into water, and the solution was of 1 liter. So we had 5 mole and 1 liter. Now you would say that the molarity of this will be 5 molar. Yes or no? You will say the molarity is 5 molar.
Yes, sir.
Only if all the salt get dissolved. Yes or no?
Yes, sir.
But if some salt is not dissolved, it is in solid form, then the molarity will not be 5. Correct?
Yes.
Right? The solubility will not be 5. Okay, it will not be 5. So this is what happens when you have, see the solubility product 10 to the power minus 23. So you can see that it is very, very very small. If I compare this to 10 to the power minus 3, then means it is very small. That means most of the salt is not getting dissolved. These ions are in very less amount. Most of the salt is not getting dissolved. Okay, so that means we cannot directly tell the concentration of a particular salt in solution by looking at the molar, how many moles we have taken. We have to look at the solubility product. So solubility product is given here. Let us say that we took some amount of, suppose we took some amount of solid. Okay, we took some amount of solid S. Fine. This is the concentration of salt that we took. Okay. Now I can say from 1 mole of this particular salt, 2s moles of A will be formed and 3s moles of X will be formed. Yes or no?
Yes, sir.
Right. Okay, fine. Now we know that KSP, this will be equal to the concentration of A3 positive squared concentration of X2 negative to the cube. Yes or no? Right?
Yes.
No problem?
No.
No problem. Okay, now you tell me, what is the concentration of A3 positive?
2s square.
2s square. Very good. 2s is the concentration of A3 positive squared. X2 negative is 3s cube. Yes or no?
Yes, sir.
Okay, so we can write this will be equal to how much? This will be 2 square and s will be to the 2 square into, I will write 3 ka cube into s to the power of 5. Yes or no?
Yes, sir.
So we can write s to the power of 5 will be equal to KSP divided by how much? 2 to the 4, 4 and 3 3s are 27. So 27, 27, 27, 27, and then 27 4s are 27 4s are 4 2s are 108. Okay, so we have been given the KSP 1.1 into 10 to the power minus 23 divided by 108. This will be the s to the power 5. So write this down, calculate this and tell me what is the value of s to the power 5. Then we will understand how to solve this type of situations, because this is in syllabus. Okay, this is going to be in syllabus. This is going to be in your syllabus. Okay, so calculate the s to the power 5. You will get something to the power 10 to the power minus 25. You'll get something into 10 to the power minus 25. Yes, guys, any answer? 1.1 divided by 102, 108, sorry.
1.01.
Yeah, correct. 1.01. Okay. Now please see how are we going to calculate s to the power. S will be equal to 1.01 into 10 to the power minus 25. Right? Yes or no? हाँ guys, बताइए. Correct?
Yes, sir.
Okay. So this you can write it as 1.01 to the power 1 by 5 into 10 to the power minus 25 by 5. Correct? Yes or no?
Yes, sir.
Okay. Now I can write this as 1.01. 1 by 5 is how much? 0.2. Correct?
Yes, sir.
Into 10 to the power minus 5. Correct?
Yes, sir.
Okay. Now moving on. I can write 1.1, 1.01. First of all, I will write this as 1.01 to the power 0.2. I can write this as 101. I can write this as. I did a mistake. I should have done this earlier only. Can I do this now also? Is there any problem in doing this right now? Wait a second. Let me just clear this out. And I will write this as root of 101 into 10 to the power minus how much? 27. This will be equal to 101, 0.2 into 10 to the power minus 27 divided by 5. This will be equal to 101 to the power 0.2 into 10 to the power minus 27 upon 5. So 5, 27, 5 is 25. Then we have here 2.0. This will be equal to how much? 4, 5.4. So we have 10 to the power 5.4 and 101 to the power 0.2. 101 to the power 0.2. You have to calculate this. To calculate this amount. This we can calculate, right? Yes or no? Tell me guys, can we calculate that? नहीं,
No, sir.
log से
Yes.
Yes, sir.
है ना, तो दिमाग लगा के log से तो हो जाएगा ये, है ना? We can calculate this by log. This is our, okay, that means if I have to calculate by log and I cannot calculate 101 to the power 0.2, 101 to the power 0.2, then the only option that is remaining is to we can just approximate that to 1. We can just approximate that to 1. है ना, 1.01 को approximate अगर हम करते हैं to 1, that is the only case. है ना, you try to calculate this, है ना, I will tell you what to do about that. 101. It is okay. You can just do this. Okay, don't worry. Don't write this all. Don't write this all. We can do the approximation here only. I can take this as 1 into 10 to the power minus 25 upon 5, and this will be equal to 0.2. So 1 to the power anything, it will be equal to 1 into 10 to the power minus 5 molar. This will be the solubility or the concentration. Hai na? So when you are asked about the solubility, so in solubility products, solubility is aka concentration, right? Because when we are dissolving something, then how much it is getting dissolved will tell me the concentration of a particular solute. It will give me the concentration of a particular solute. Done?
Yes,
Now
sir.
you guys tell me. Now you guys tell me. Are you guys going to school?
Yes,
No,
sir.
Yes. No.
Yes, sir.
No, sir.
no, sir.
Online चल रहा है online.
Yes, sir. Online.
Online it's happening now. Now what you will do? You will ask your teacher about the question number 7 point. Not 7 point. 7.72 and 7.73. Okay. Fine. You will ask your teacher about these two questions in your NCERT. Now you can ask about 7.71 also, because there are a few questions which depends on the concept of ionic product and the precipitation. These are the precipitation question, last 3 questions. Okay. And so you ask her about these 2 questions, okay, especially, and ask her that if they are coming examinations or not coming examination. Okay, fine.
Okay.
Yes or no? Okay. So tomorrow we are going to meet now. So you will ask tomorrow and tell me tomorrow. Aisha.
Okay, sir.
Okay. Samaira, Sarah, Zainab, bataiye, all of you.
Yes, sir.
Yes.
Okay. So if you will ask tomorrow and tell me tomorrow, then it's a very small concept. We can do a few numericals and it will be okay, because we have already done KST. Okay. So that's it for today. Equilibrium is now done. Equilibrium is now done. So what we will be doing is from next Tuesday, right? Tuesday.